Alright guys, so this is going to be a video that I usually do on my channel. So I'm actually studying to be an electrical engineer right now, and over the course of my studies I've actually gotten an appreciation for math. So I want to make just a 3-part series about like some of my favorite famous math equations. And the first one I'm going to do is the Basel series, which is the sum from n equals 1 to infinity of 1 over n squared. And I'm going to be doing this like through an intuitive means. So we're going to be doing the integral method. But I am going to do this one again, actually, through a different method. So for this video, you need a strong knowledge of Calc 3 and Calc 2 in order to fully understand everything I'm doing. But anyway, let's go ahead and get started. So we can write this 1 over n squared term as an integral. So we have the sum as n equals 1 to infinity, integral from 0 to 1, integral 0 to 1, and then we'll have xy n minus 1 dx dy. Okay. Now we have that. So we can keep going. I'll zoom in. Oh, okay. So we can keep going now. Now we can actually bring the sum inside the integral because it converges. So we get the sum n equals 1 to infinity, and then we're going to have xy n minus 1. Then we're going to have dx dy. Like that. Now, this is actually a geometric series. So that means that it converges to a over 1 minus r, where a is the first term and then r is the rate. So if we plug in a 1 here, we get xy to the 0th power. So a is just 1. Yeah, that's going to be 1, and then the rate is xy. So each successive term increases by xy. So just 1 minus xy. So now we can replace this whole sum term with just that. So we end up with this double integral 0 to 1, 0 to 1 of 1 over 1 minus xy dx dy. So now that we have that, we can keep going. So now that we're here, we actually solve this with a clever substitution. So we let x be equal to u plus v, and let y be equal to u minus v. All right. So now we just got to find the bounds of the new region. But first we need to take the Jacobian. So the Jacobian is just the partial derivatives with respect to the new variables. And it's the matrix, it's the determinant of the matrix of the partial derivatives. So the Jacobian, and we use absolute value in the integral. So the Jacobian of this is just going to be partial x with respect to u, partial x with respect to v, partial derivative of y with respect to u, and the partial derivative of y with respect to v. So that's just going to be 1, 1, 1, negative 1 to give us a Jacobian of negative 2. Now that we have that, we can actually start finding the bounds now because we're going to need that Jacobian later. We'll actually value the Jacobian. So uh, so let's just solve for it algebraically. So u is going to be equal to x minus v, and now we plug that into the y one. So that's going to be y equals x minus 2v. So v is going to be equal to x minus y over 2. Now let's do the same thing for v. So v is going to be equal to x minus u. Plug it into the second one, and y is going to be equal to y is going to be equal to sorry, 2u minus x. So now u is going to be equal to x plus y over 2. Okay, now that we have this, we can actually start getting the bounds. So the set of equations So remember, this is a rectangular region. So if you was to sketch the region, it would just be a square. So the coordinates are actually 0, 0, and this is going to be the form x comma y. And then it's going to be 0, 1, 1, 0, and then 1, 1. I guess I can move this a little bit. Okay. So now we're just going to convert this into the UV plane. So this is going to be in the form u comma v. So 0, 0 just stays 0, 0. And the cool thing is, if you actually sketch the UV plane, u is actually would be on the xy plane, the line y equals x, and v on the xy plane would be the line y equals negative x. So the square would actually just be rotated 45 degrees in the at UV plane if you actually want to draw it. I have a graphic that I might add in at the end. But anyway, so 0, 1 becomes a half, and then here it becomes negative a half, and then this also should still be a half because it's 1, 0, and then here it's going to be positive a half. Now 1, 1 it becomes just 1, 0. All right, so now we have the points. But on this region, I'm going to write my integral in the form. I'm changing it from dx dy to dv to u. So u is a constant, right? But v is actually changing with respect to u. So we actually got to figure out the bounds for u. So x is changing from 0 to 1. So 0 is going to be x. Sorry, is going to be u plus v, and then 1 is going to be equal to u plus v. And then y is doing the same thing. So 0 is going to be u minus v, and then 1 is going to be u minus v. So now we just write v in terms of u. So I'm just going to do it like this. V equals, so it's going to be negative u. Then it's going to be 1 minus u. Then it's going to be u. And then it's going to be u minus 1. If you do everything over and simplify. Now, the bound. So notice when it's right here, 1 half, negative a half. So that corresponds to v equals negative u. You use a half, so v equals negative half. Then right here, u equals u, that corresponds to this, because when it's a half, v is also a half, so v equals u. And these all correspond to the other bounds. So now that we have that, we can actually start writing bounds. So u is changing, so notice how there's two 1/2s, right? So that means we have to split the integral up. So this is going to be the integral from 0 to a half, then the integral from negative u to u of 2 over, we got to do, so we had x times y, right? So we got to actually do x times y. So that's going to be u plus v times u minus v. And that just gives us u squared minus v squared. So this is going to be 1 minus u squared plus v squared. So remember, it's 1 minus xy. So you just flip the negative sign. Now we do dv, du. Okay. And, well, okay, there's going to be another integral too, but this paper is kind of small. Can I change that? So let's just focus on this integral first. But I'm gonna write another one, and I'm gonna do it in red. Now I'll do it in blue. So this is also going to be another integral. So it's going to be plus integral from 1/2 to 1. Then it's going to be the integral from u minus 1 to 1 minus u. Because remember, u is less than 1. So if we plug in a half, that'd be 1/2 minus 1, which is negative a half. And then if we plug in a half here, it'd be 1 minus a half, which is positive a half. So that's how you know it's the correct order. Then it's going to be 2 over 1 minus u squared plus v squared dv du. Okay, now that we have this, we're going to focus on the black one first. So I'm going to be writing in black from here on out, and we're going to focus on the black one. After we get what it converges to, what it equals to, then we'll focus on go back to the blue one. So Let's just focus on the black one for now. So we're gonna do a substitution here. Actually, no, we're not. I just like to wrap my variables into one. Makes it a little bit easier to solve. So I'm gonna say let k squared be equal to 1 minus u squared. So now this integral is just 0 to 1/2. Integral from negative u to u, and then it's gonna be 2 over k squared plus v squared dv du. Okay. Now we actually can solve it with the trig sub. So we're gonna let v equal k tan theta. So dv is going to be equal to k secant squared of theta d theta. Now that we have this, we can change the base. I'm not going to change my bound. Just keep in mind that it's no longer in the theta. It's not like theta equals that. It's going to be v equals that. But I just don't want to write v equals that. So I mean, technically, I should be doing this, and then 2 over. So that's going to be k squared plus k squared tangent squared. Factor out the k squared, so that's going to be k squared times the quantity 1 plus tangent squared, that's secant squared. So this is going to just be k squared secant squared of theta. And then we got to multiply that by the dv, which is now in terms of theta, so it's going to be k secant squared of theta d theta. And we don't forget the du. Well, it's there, it's just now these secant squares cancel, and this k cancels with one of these k's. So we're just left with 2 over k. Now, that's actually a constant in the theta world. So this is gonna be just an integral of 0 to 1/2, and then it's gonna be 2 over k, and then it's gonna be theta. So let's just go ahead and figure out what theta is, because that will save us some time. If I draw a triangle and I have theta. So remember, when we first made the sub, we said v equals k tan theta. Tangent is the opposite over the adjacent, right? So this is going to be v, and this is going to be k. So what is k? K is the square root of 1 minus, oh, sorry. Yeah, 1 minus u squared. Because remember, let k squared be equal to that. So we got to take the positive square root due to the domain. And yeah, so theta is just going to be the inverse tangent of v over that, right? So that makes it really simple. So this is just going to be, and I'm going to write that as arctan of v over root 1 minus u squared. So now that we have that, we can keep going. Now we evaluate that from negative u to u. So, and again, this is inside the thing, but I just do it like this just to make it a little bit easier to look at. So this is going to be, u over root 1 minus u squared. And then it's going to be minus negative u over 1 minus u squared. So now this negative cancel, and we end up with the same argument. Because remember, inverse tangent is a odd function, so you can bring the negative inside the argument and cancel out with a negative, with this negative inside the argument. So that means they have the same base. So that becomes 2 arctan, and then there's already a 2 outside. So we end up with a 4 arctan, and hopefully that makes sense. Hopefully I'm not skipping too much steps. And if I am, just leave a comment and I'll answer it. So this just becomes the integral from 0 to 1/2. And then that's going to be 2 over square root 1 minus u squared. I guess I really should have added that back in this state. There we go. And then it's going to be, instead of a 2, it's a 4 now. It's going to be 4 arctan. And then it's going to be just a u over 1 minus u squared, because the argument's the same. Now that we have that, well, of course, I'll get du. So now that we have that, we can actually solve this integral. So we're going to actually do another substitution. And when I first did this, I used S, but I'm gonna use like A, just so it doesn't look like a 5 or anything when I'm writing. So the tan, we're gonna let the tan of A equal to u over root 1 minus u squared. So multiply both sides by root 1 minus u squared. Tan A equals u, and then we're going to square both sides. So we end up with 1 minus u squared times the tangent squared of A equals u squared. Now we're going to expand out. So we're going to have the tangent squared of A minus, actually, I'm just going to go ahead and move it to the other side. So it's going to be equal to, I'm going to factor out the u squared. So we're going to end up with 1 plus tangent squared of A. So that's the same thing as secant of A, or secant squared of A. So that means u squared is going to be equal to the tangent squared of A over the secant squared of A. And that just means that u is going to be equal to the sine A, because secant is cosine. So that's going to be sine squared of A over cosine squared of A times cosine squared of A, because on the that's 1 over cosine on the bottom. So as a complex fraction, you multiply by cosine squared, so you end up with sine squared, and then we're taking the root, the positive root, because of the domain, and then we end up with just sine of A. So now that we have that, now that we have that, we can keep going. So u equals the sine of A, so that means du is going to be cosine of A dA. Now we can finally rewrite this whole integral. So that's just going to be the integral from u equals a half to u equals, u equals 0 to a half. And then that's going to be 4a, because remember we said a is going to be the arctan if we solve for a. So a equals arctan u over root 1 minus u squared. So that's going to be 4a. And then it's going to be over, let's just think of this through until we save room. So u equals sine of a, right? Then the u squared is going to be the sine squared of a. So 1 minus sine squared is cosine squared. Then we're taking the root of that. So that's just going to be cosine a times cosine a dA. So these cosines actually cancel. And what we're left is just, we're going to get 2a squared. Evaluate that from u equals 0 to u equals 1/2. But what is a? Remember, a is the the arctan. So this is just going to be the arctan squared. So it's going to be 2 arctan squared of, remember, the argument is still u root 1 minus u squared. Now it's going to be from 0 to a half. Now that we have that, we can plug in 1/2. So we're going to get, so one, that'll be, I'm just going to write it out right here. So it's going to be a half over, so that's going to be 1 minus a fourth, which is going to be 3/4 inside the root. So that's going to be 1 over 3 over 2, because you can, the 4 is a square. So now we multiply top and bottom by 2 because it's a complex fraction. Then we get 1 over root 3, which is the same thing as root 3 over 3, because you rationalize the denominator. And now tangent equals root 3 over 3 at pi over 6. So this is pi over 36. Multiply that by 2, you get, it's pi squared now because of the square root. So pi squared over 18 now. So that's the answer for the first integral. Now we just need to go back and focus on the second integral, add them together, and we should get what the sum converges to, which, by the way, is pi squared over 6, famously. And then when I do my next video, you'll see it again, but it'll be way quicker because there's less work involved. But it's less intuitive because we're going to be talking about things at infinity. So anyway, now this integral we're going to do the same substitution, by the way. So we're going to end up with the integral from 1/2 to 1. Then the integral from v equals u minus 1 to v equals 1 minus u. And then there's going to be 2 over k squared plus v squared dv. Oh, actually, I didn't even write that yet. I was getting ahead of myself. Write that out. So it's going to be. Oh, I did it wrong over. I'm so confused. What am I doing? Okay. So it's going to be u minus 1, and then it's going to be 1 minus u. And don't forget the dv. Now that we're here, we'll do the same sub. So, and I somehow, how do I do that? So it's going to be v equals k 10. Now, dv is going to be k secant square root of theta, d theta. So it is the same position, by the way. So if you don't mind, I'm just going to go ahead and skip some steps because it's the same thing. And then, so this is just going to be, it's going to be just 2 over root 1 minus u squared. And then it's going to be arctan of v over 1 minus u squared. Now we're going to evaluate that from 1/2 to 1. Sorry, no, we're not. We're going to evaluate that from u minus 1 to 1 minus u. So again, keep in mind that this is all inside the argument of the arctan. So there's going to be 1 minus u over root 1 minus u squared. And then it's going to be minus u minus 1 over root 1 minus u squared. And remember, we can bring the argument inside. So when we bring that inside, this just becomes 1 minus u over root 1 minus u squared because it's an odd function. Remember, you can't do that with even functions, only for odd functions. So plus 1 minus u squared over root 1 minus u squared. So now we have the same thing again, right? So now we have the same exact thing. That should not be a square there. So now that means we can actually combine them. So this just becomes the integral from 1/2 to 1. That's going to be 2 over root 1 minus u squared. And actually, it's not going to be a 2, it's going to be a 4. So 4, that's going to be arctan, and 1 minus u over root 1 minus u squared. And the all right, now we're getting somewhere. And now we do the same thing that we did earlier, except now it's a little bit more different because we have that 1 minus u term there. But it's the same thing. So I'm just gonna let the tan of b this time be equal to 1 minus u over root 1 minus u squared. So now we have that. Now we multiply both sides and square it. So we'll end up with okay. Sorry, I got someone was talking to me for a second. So yeah, so we end up with just doing that. Root 1 minus u squared tan b equals 1 minus u. Now we're going to square both sides, so we're going to end up with 1 minus u squared tan squared of b equals 1 minus u squared. Don't actually expand. It's way easier to just divide it out. So tan squared of b is going to be, we're going to write this as 1 minus u times 1 minus u, and then divide that by, that's a difference of squares, so it's going to be 1 minus u times 1 plus u. So now these actually cancel, and we're going to get the tangent squared of b is going to be equal to 1 minus u over 1 plus u. Now we multiply on both sides and expand out, so that's just going to be that's going to be just 10 square root of b equals, let me go ahead and subtract that 1 over. So 10 square root of b minus 1 equals, factor out the u, and then we're going to end up with minus 1 minus 10 square root of b. Now we just divide that over. So that means u is going to be equal to the tangent square root of b minus 1 over so let's say I factor the negative 1 out. So that's just do that. That makes it a little bit lighter. Plus tangent squared of b. Now 1 plus tangent squared is secant squared. So that's going to be 1. U equals 1 minus tangent squared of b over secant squared of b. So that's going to be equal to sorry about that. Dropped it. And that's actually going to be equal to the cosine of the cosine of 2b. So let me just explain it out. We might as well show the steps. So that's going to be the cosine squared of b. And then remember we said earlier, that's going to be minus the sine squared of b. And that's the what's one of the identities for cosine of 2b. So that's going to be just the cosine of 2b. So if you want to show some work. So that's that. Okay, now that we have that, we just do the same thing we did before. So du is going to be minus 2 sine of 2b db. So now that we have that, we can actually just rewrite this integral. So that's just going to be the integral from u equals 1/2 to u equals 1 of 4b. So you have 4b, and then that's going to be over, remember, we have in the square root 1 minus u squared. So 1 minus u squared, u is cosine of 2b. So that's 1 minus the cosine squared of 2b. So that gives us the sine squared of 2b, and that's in the square root. So that just becomes the sine of 2b. Now we're going to multiply that by negative 2 sine of 2b db. Now these sine squared. No, it's not. Wait, hold on. Yeah, this should just not. This not. Oh, it's a little bit more difficult. Okay, I'm just gonna erase all this bottom part. So we had, like we said earlier, we have the sine of 2b. I don't know why I squared it. That's going to be minus 2 sine of 2b db. Now this cancels and that cancels. And then we're left with just negative 8b in the integram. So that becomes 4, well, negative 4b squared. Now, and of course evaluated from u equals 1/2 to u equals 1. Now that we have that, we can remember what b is. So b is the arctan of the inside. So that's just going to be arctan squared. So it's going to be negative 4 arctan squared of 1 minus u over root 1 minus u squared. So now, if we plug in 1 directly, we'll get 0 over 0k. So we actually have to simplify this a little bit. So that's just going to be equal to -4. So I'm just going to write down the inside what I'm doing. Then I'll just write the tan down. So on the inside, we can write this whole thing as a square root. So we're just going to have 1 minus u squared. And then we can write this as a product. So let me go ahead and write that as a product. So that's 1 minus u times 1 minus u. And then down here, that's the difference of squares. So it's going to be 1 minus u times 1 plus u. These cancel. Now I can plug in a 1. So that's going to be a 0. The arctan of 0 happens at 0. So this is just going to be 0. Then it's going to be minus 4 arctan squared. Now we got to plug in the 1/2. So this is going to be minus a minus, so that's going to be plus, because it's a -4, remember? So that now we plug in the 1/2, so that's going to be 1 minus a half, that's a half. Now, over here is going to be a fourth, it's going to be root 3 over 2. Now multiply both sides by 2, because remember, it's literally the exact same thing. So now it's root 3 over 3 again, and that happens at pi over 6. So now that's pi squared over 36. And then it's divisible by 4, so you end up with pi squared over 9. All right, now let's add them together. That's going to be pi squared over 18 plus pi squared over 9. This becomes just a 2 pi squared over 18 plus pi squared over 18. That's this term, by the way. So that becomes 3 pi squared over 18. 18 divided by 3 is 6, so we're going to end up with pi squared over 6. And that's the correct answer. And I'll plug in, if you don't believe me, proof of that. And anyway, thank y'all for watching, and hopefully y'all will enjoy the next couple of videos like this as well. Okay, now I'm just going to end the video.